Welcome. This is lesson 6.3, solving compound inequalities. First, we're going to look at our definition. A compound inequality is simply two inequalities in one inequality. Now, there's two types of inequalities. There's the and inequality and the or inequality. An and inequality means both solutions must be satisfied or both must be true, or means that one or the other, so just one needs to be satisfied. So, an example is all real numbers that are greater than 0 and less than or equal to 4. What that would look like is you would say x is greater than 0, so that's one inequality, and less than or equal to 4, x is less than or equal to 4. Now, and statements can be written together if you want to. So you could write this as 0 is less than or equal to x, which is less than or equal to 4. Sorry, less than 0 is less than x, or less than or equal to 4. Now, when you graph this, what it would look like is on 0 you'd have an open circle, and on 4 you would have a closed circle. But if you're greater than 0 and less than 4, it's this grouping of numbers right in between 0 and 4. Now, in the or inequality, it says all real numbers that are less than or equal to -1, so x is less than or equal to -1, or x is greater than 2. So there's no way of bringing that together. It stays separate. So when you look at the graph of that, on -1 it would be closed, and that would go to the left. On 2 it would be open, and it would go to the right. So when you have to approach the and or the or inequalities, and most of the time come together, and or most of the time go apart from each other. So, just an example of what that would look like, or a few examples here. First up is all real numbers less than 7 and greater than 1. So that is x is less than 7 and x is greater than 1. You have 0, you have 1, you have 7, because it's an and, open circle on 1, open circle on 7, and they get connected. X is less than 7 and greater than 1. For number 2, all real numbers greater than 5 or less than 0. X is greater than 5 or x is less than 0. On 0 it would be an open circle, it would go to the left. On 5 would be an open circle and it would go to the right. So again, the and statements most of the time come together, ors should go apart. If you look at number 3, all real numbers greater than or equal to -1 or less than or equal to -6. So x is greater than or equal to -1 or x is less than or equal to -6. You would have 0, you'd have -1, you would have -6. Greater than or equal to -1 would be closed and to the right. X is less than or equal to -6 is closed and to the left. So your or statements again went apart from each other. In 4, all real numbers greater than or equal to -3. So x is greater than or equal to -3. And less than 10, x is less than 10. So 0, -3, 10. Closed circle on -3, open circle on 10, and they come together. So that's about it when it comes to actually writing and graphing a basic compound inequality. Now we're going to take a look at solving a compound inequality. So the one rule still applies. If you multiply or divide by a negative number, you need to flip the inequality symbol. So we're going to take an example of solving these and just seeing what happens. Now, number 1 is an example of an and inequality. So what's happening here is there's two inequalities in one. The 2x plus 3 is going with negative 5, and the 2x plus 3 is going with 7. I'm going to solve this as just one large inequality. So I'm going to subtract 3 from both sides. That's going to leave me negative 8 is less than or equal to 2x, which is less than 4. Then I'm going to divide all three sides by 2. So negative 4 is less than or equal to x, which is less than 2. So what that's telling me is that x is between 2 and negative 4. So if you look at the graph of that, you'd have 0, you'd have 2, you'd have negative 4. On negative 4 it would be closed, on 2 it would be open, less than 2 goes to the left, greater than or equal to negative 4 goes to the right, and it connects right there, as that end statements usually do. In 2, you'll see the word or between it. Or stays there. It's going to stay between these two, and you just solve each one on its own. So on the left side, it says 6x minus 5 is less than 7. I'm going to add 5 to both sides. 6x is less than 12. I'm going to divide out the 6. X is less than 2. Or subtract 1 from each side. 8x is greater than 24. Divide out the 8. X is greater than 3. So if I go to graph this, you still have your 0. Then you have 2. And you have 3. X is less than 2 would be an open circle, and it would go to the left. X is greater than 3 would be an open circle. It would go to the right. And this or statement, again, stays apart from each other. Then the last one we're going to see is an and statement again, but it's going to bring up an interesting rule. We have negative 3 is less than negative 1 minus 2x, which is less than 5. To get x by itself, I'm going to add 1 to all three sides. That's going to leave me negative 2 is less than negative 2x, which is less than or equal to 6. Now to get x by itself, I'm going to have to divide out the negative 2. When you do that, that flips both inequalities because you're dividing by a negative. So this becomes positive 1 is greater than x, which is greater than or equal to negative 3. So if you go to graph this, it's kind of strange when you see it in this format, but x is less than 1 is open on 1 and it goes to the left. X is greater than or equal to 3 is closed and it goes to the right, and that's your final answer of what this would actually look like. So the end statement that actually comes together in that case.